Good morning. Welcome to Puppet Camp Boston. I lived here for quite some time. Went to school here. I worked here, I think, pretty much between 2000. Well, no, I count school in 1996. Probably took far too long. I would say UT. But, it's cheap, so that worked out well. All the way through maybe like 2008. So it's always good to come back to town. Although maybe next time I'll come when it's like not right on the cusp of all the South by Southwest madness. I was looking at hotel prices. In fact, I was debating maybe staying an extra couple of days or like a week, and then I was looking, it's like, wow, the Hampton Inn wants like $1,800 for a night. So obviously I'm in the wrong land. Right, so tradition dictates at a puppet camp that we start with, we begin with the raising of hands / shaming. All right, so first up, put your hands up if you're actually using Puppet right now. Okay, so that's maybe 40%, something like that. I don't know. Again, I went to state school, I can barely do that. Who is using some other automation tool, like other than Puppet, but something else? Okay, that's 10%. Who is using some automation, but it's stuff that they wrote themselves? It's okay. There's no shame yet. Who is not doing any automation at all, but is interested? Okay, there's a couple folks. It's all right. You've come to the right place. And if you had to describe yourself as someone that was new to Puppet, how many of you would that cover? Okay, so that's about half of the room. So, okay, that's sort of what I expected. It's very interesting. So I've been doing these for, I've worked for Puppet Labs. I'm the director of engineering there, and I run most of the engineering on the platform. So that's most of the core stuff that people that use Puppet are probably already using. So that's the Puppet Agent, the Puppet Master. I was one of the lead developers on Puppet TV. Alongside a few other things. But I've been there for about 4 years, and I think we've kind of transitioned from the point where, even as recently as maybe 18 months, 24 months ago, you would talk to people at these, and it was very much the community was primarily focused on, bleeding edge, early adopters, people that kind of know what they want, they know what they're getting into, they can take all this stuff, apply a bunch of digital duct tape, and get all these things going. And I think it's interesting that now we're kind of approaching, more people are interested, more people are hearing about the benefits of automation, which is great, because I love the idea of kind of bringing people into the fold. So I think that benefits us all. All right, so, the high levels, the TLDR, I guess is what I'm going to be talking about, is basically, kind of a sort of a survey of landscape, in terms of, what do operators typically need to deal with at this point in time, what are the challenges that they're facing, what stuff is coming up, and then what are we doing as a community and as a company to try and address those kinds of things. So this is the least controversial slide ever. And I like it because I can copy and paste it for any talk that I ever do for anything. It'll work at bar mitzvahs and funerals and whatnot. Maybe not. I don't do a lot of presentations at funerals. I have the perfect body count record for all my talks, so no one keel over. So I would say that, this is again probably another somewhat meaningless statement, but I would say at no point in time has IT been sort of as vibrant as it kind of is right now, which is a bit of a facile statement, right? Because next year it'll be exactly the same situation. But I think at this point, most people I think are starting to realize that there was kind of the phase of IT and systems administration that kind of existed, maybe in the 90s, maybe in the 2000s, and I think we're kind of approaching a very different, kind of era of system administration. Like there's way more pressure now, I think, in pretty much any business there is to move much faster than they currently are, just because it's so easy for your competition to move potentially faster than you, in which case you're kind of hope your resume's up to date. There's new technology that's coming out all the time. Whatever the hot thing was that you thought you were really avant-garde for taking advantage of, 6 months ago, that's super passé and lame now. I assume everyone is running Node.js apps on Raspberry Pis, plugged together into some kind of package form. But just wait, 18 months from now, that's all going to be useless. But it's fantastic because it's continuous employment, I suppose, for everybody. But probably the biggest thing is methodologies and culture, I think, in many ways needs to catch up with the pace of change that's actually happening. So what does that mean for the sysadmins of the world? This is documentary footage of the system administrator. That's why it's in black and white, that's, it's true. So the life of the sysadmin, I would say, is oftentimes difficult and tedious and sometimes thankless. There's sort of the idea of the sort of the hero paradox, right? Which is house is on fire, fire department comes in, they put the fire out, save the cat, everything works out great. They get handshakes, they've done something heroic, right? Something was on fire, they put the fire out, everybody can see the heroic effort that went into that, right? So we can all applaud, and that's fantastic. However, there's a different group of people. Maybe the sysadmins of the fire department world or something like that, the equivalent where, I don't know, maybe they work on building codes to make sure that there are fire breaks in certain areas, safety regulations, things like that. One could argue maybe if they do their jobs correctly, way more fires have been suppressed. They never happen. But I think oftentimes because they never happen, there's never a dramatic moment that requires these heroic efforts. It's through the sustained effort and sustained heroism that tends to make a lot of these things better. And I think oftentimes in sysadministration, sysadmins kind of get into this situation where if stuff is breaking all the time, but you're getting paged, I woke up at 2 in the morning, I went in and I restarted this thing and I fixed it and then everything was great. You come in the next day, you do that all the time, everybody thinks you're a really hard worker, you're doing a ton of great stuff. However, contrast that with someone who's maybe like, maybe I'll design my services so it'll automatically do that so I don't have to wake up in the middle of the night. I think one is clearly more optimal, but I think in many ways, a lot of shops don't necessarily recognize, historically anyway, I think there was maybe less recognition for, people that kind of take the long view. But I think a lot of that's changing. I would also say that, statistically, because they've done studies on stuff like this, and effectively, this is not a surprise to anyone. Sysadmins get interrupted all the time. And I think on average, most of the studies that have been done say, usually once every 15 minutes. How many people here feel that they are interrupted once every 15 minutes? All right, the system works. The interesting part, though, is those same studies say that after you're interrupted, it takes you about 30 minutes to recover from that interruption. So, you do the math, it's sort of like the myth of Sisyphus. He's like pushing that boulder up the hill, and then when he gets it to the top, it just rolls back down to the bottom again. You have to repeat the cycle for infinity. So I think you combine that with this constant pressure from the business to do things, faster for less money with fewer errors. And in many shops, it's kind of a recipe for burnout, or at the least, it's not a recipe for job satisfaction. But I think the most important consequence of this is that oftentimes you don't have time to focus on things that are genuinely meaningful for the business that you're in. Right? I'm pretty sure no one here is in a company where the primary revenue generator of the company is due to you changing passwords on systems all day, right? If I just change 20% more passwords, my share price is going to go up. That never happens. It never happens. But obviously, that stuff needs to occur so that the business can get on with doing stuff that actually gets you a paycheck at the end of the day, right? But I think oftentimes if you're stuck in this cycle where you're constantly fighting fires, where you're constantly interrupted, and you don't have any time to actually think about higher level strategic things that could legitimately move the business forward. And that's a problem for everybody. Because, obviously if you're in an organization that's not really doing a whole lot to impact the business's bottom line, and you're not demonstrating a lot of value, then, that can cause problems. And, ultimately if you're in a company that's not making money, then it kind of doesn't matter how awesome you are at changing passwords, right? I don't know, that password changing business sounds like interesting. Bitcoins can work. Surely it should have a password coin kind of thing. So ultimately, I think what this means is that at this point, I don't think there is a single company really in pretty much any market or vertical that isn't a technology company in some way, shape, or form. Pretty much every business is a technology business. at this point. And I think it's very interesting to contrast sort of what's happening now with what happened in maybe the kind of late 90s, early 2000s, when at that point in time, everything was like, oh, well, we're not really a technology company. We don't need to be good at software, so we can just outsource all of that to people that are. And that'll work out great. Spoiler alert, it did not work out so great. And I think at the time, people just felt that, well, none of these things are strategic. Of course we can outsource this stuff, because that's not the core of my business, right? But now, I think the people have spoken, and that just didn't work. So now you're kind of seeing the opposite, where now people are starting to insource, more of these things so that they can have more control, tighter control over how more aspects of their business actually works, because everything's a tech company. And that's not to say that everybody is taking on everything inside of a single company, right? Like there's definitely like the rise of SaaS and things like that, where certain things make sense to punt, to a different vendor. But definitely now more so than 10 years ago, I think there's a much wider variety of kind of ownership inside of companies for a larger part of that tech stack than there used to be. And ultimately, I would say if technology is not a competitive advantage for you in the company that you're at, then it's probably a competitive advantage to a competitor of yours. I think this is what, when big industries get disrupted, that's usually why. It's usually superior application of technology to the same problem that all the competitors are trying to do, but they can't do it fast enough. And if you can't do things fast enough, you can't learn from, actually trying things. And generally, the businesses that can learn more quickly are the ones that tend to, weather the storms, changing market conditions and things like that. So, tech is important. So, it's good. Because, we're all in the ones and zeros business. But it is not the technology alone that's important. Like, you can't just say, well, if I just adopt these tools, that's going to make my life as a system administrator, it's going to be a million times easier. Like, it's a combination of a great many things. I assume everyone here is familiar with the concept of DevOps. Is anyone not? Can anyone here define what DevOps is in a sentence? There we go. So this is a tough one because everyone knows what it is, but no one can actually tell anybody what it is. I don't know, it's like the Fight Club of IT. Or like Cthulhu or something like that. I think the way I like to describe this is sort of by maybe what it's not, or what would generally be considered to be like anti-packaging, because it's not sort of the DevOps way of doing things. I would say, in the old world, in the long ago, I think it was very easy for operations to be basically like, it's the party of saying no. That's what if there was like a political campaign for, systems administrators like, 10, 15 years ago, it's like, no, we can't. Developer needs this thing and I need it in 2 days. Like, can't do that. It's gonna take a couple of weeks. I need new gear. You're not gonna get that when you need it. I need to run a new operating system to do something. Like, that's not the standard. I need to open this port. You're gonna have to talk to 15 different groups and get approval for that kind of thing. So I think what DevOps is broadly about is kind of that transformation between the party of no to the party of yes. Sure, of course we can do that, because why wouldn't we? Because that's easy to do. And I think that's kind of what everybody wants. And I think a lot of what DevOps is trying to get at is culturally and technologically changing the shape of IT so that we move more in that direction. So we do a survey every year. It's pretty big. I think for 2014 there was literally over 9,000 respondents, so individuals, organizations, things like that. And we have posts on the Public Labs blog where we talk about statistical analysis and stuff, where we go through it for the numbers nerds in the audience, which I'm one of them. But basically, it's really easy in a lot of these surveys to say, survey taker, are you DevOps? Do you have like 12 killer DevOpses? And yes or no? So I think instead of focusing on that, we were asking folks about certain practices, that tend to be correlated with kind of the DevOps. Do you use revision control? Do you do continuous delivery? How is your organization structured? And those kinds of things. And I think more importantly, what we were trying to do with this is actually try and statistically correlate Like, if you're a business and you use certain practices that are generally considered DevOps practices, did that actually make a difference? Like, did you make more money? Are people's job satisfaction increasing? Is everybody happier? Is the business doing any better? Because if you're not, then maybe this is all just a load of hot air. But the spoiler alert though is it's not, which is good, because I think that's kind of where everybody is sort of aligned, right? And I think to a certain sense that, in a certain aspect, that's common sense, but I think it was good to actually back this up with, some numbers. And sort of the top line conclusions, which I thought were really interesting, was that effectively, IT departments that work really well, that's a competitive advantage to companies, because the ones that tended to actually have higher market capitalization, higher revenue numbers, they also tended to have what they would consider to be very high functioning IT organizations. So that's pretty good, because I think what that means is pretty much everybody in this room, if you were able to significantly up-level the pace of change that you could accommodate, or the services that you provide, or the service levels that you're providing, that's genuinely impactful to the business. And that the sort of the billing of the subheading of that was basically firms with high-performing IT orgs were twice as likely to exceed their profitability, market share, and productivity goals. Twice as likely. So don't let anyone tell you that IT doesn't matter. The other one was DevOps practices tend to be correlated with improved IT performance. So high-performing IT, you get more money, and if you tend to do DevOpsy things, you tend to have higher-performing IT. And that's, again, correlated with practices like, use of continuous integration pipelines, some kind of continuous delivery thing, rapid deployment, like frequent deployment, sort of more agile types of operations. And the interesting thing was the longer companies have had that kind of ethos going on, the more improvement that they actually saw from it. So, again, if you can actually dial in these practices and kind of change the culture, that not only benefits the business, but that benefit will increase over time. Organizational culture was definitely one of the highlights, I think, of the survey, because the culture of the org that you're in turned out to be one of the strongest predictors of IT performance. And I think this kind of makes sense, right? Because again, if you're just one team in a sea of a zillion people in your company, and no one outside your team really is invested in making sure that we can deploy software faster, then there's only so much people can do in isolation, right? I mean, I'm sure everyone here has some level of control over some slice of the stack, right? But ultimately, the companies that tend to do the best are the ones that focus kind of full spectrum, and it's more of a cultural change. How many of you have been in places where you've tried to implement sort of DevOps-y kind of practices, but were met with sort of institutional resistance from the rest of the company? Okay, so I mean, that's a lot, right? And that's tough, but I mean, obviously I think what that tells people, and this is nice because this goes out to, the boss's boss's boss, and it's got a bunch of pretty pictures and it's color-coded so they can understand. It's blue, orange, it's friendly. It looks like an IKEA catalog. But been buying a lot of furniture lately. But yeah, I think, I don't think the numbers lie. Like, it's the kind of thing that needs to be approached, not just for groundswell, like individual system administrators or teams that think that this is the way to do things, but there also needs to be support also, from the top down. And those two things need to meet in the middle. You can't change these things overnight, but you definitely need kind of institutional support in order to make this stuff happen. And the last thing that I actually thought was really interesting, especially with the rep that a lot of sysadmins get for being, kind of curmudgeon-y, is that actually the number one, aside from all the other stuff I said, the number one predictor of organizational success and performance was job satisfaction. Which again, kind of makes sense if everybody's going around like, well, this job sucks, but, at least the hours are terrible. Like, you're not, the newsflash, that's probably not going to be a fantastically performing organization, right? And, I obviously, because I was a system administrator, as a developer for a long time, like, I have a very vested interest in making the world better for people that do the stuff that I do. And I think, basically, what is it, what do people correlate with high job satisfaction? And a lot of it, again, kind of relates to a lot of these DevOps concepts, right? Like, people want to feel empowered to make decisions, right, that actually have some real impact. And if you work in an org where every decision you want to make has to go through like 15 million gates from 100 different groups, like how empowered do you really feel, right? Because sort of empowerment oftentimes is directly related to how much responsibility you have. And a lot of these things and a lot of the ways orgs have been set up historically is to kind of take away responsibility from people. Whereas I think kind of a big part of the DevOps movement is to try and put more responsibility in the hands of people that are skilled practitioners. They kind of know what they're doing. Give them the tools to help automate away a lot of those gates, because it's not like the gates themselves are unimportant. It's more the implementation of them isn't super important. Like obviously, no one wants to deploy stuff that takes down your entire production instance, right? But that doesn't mean that maybe the way to go about that is to only roll out one change every 2 years. I mean, you could do that, but I mean, I don't know, who was using Uber 2 years ago? How many taxi companies knew about that? Probably none, because it didn't exist. And now, how many taxi companies know about that? Basically every single one. So, the amount of time, there are literally companies I've talked to where they do things like that. We only deploy once a year, once every 2 years. It's like, that's literally, in 2015, that is enough time for a competitor to basically get some folks in a garage and actually build something that, significantly disrupts what you were trying to do. So yeah, DevOps is a big deal. Obviously, at this point, I think, and this is interesting, I think maybe even as soon as maybe 4 years ago, 3 years ago, I think that there are still plenty of organizations that I think would have approached sort of cloud resources with trepidation. We don't control it, it doesn't meet these security standards, things like that. And it's interesting because, I'll talk to investment banks and hedge funds now where, we run a bunch of stuff in AWS. We have to run it in there like, they're PCI certified, thingamajig, but it all works. And I was like, oh, that's pretty interesting because usually, now you're starting to see penetration into industries that have traditionally been like mega lockdown and things like that. I mean, I don't think we're going to have like military stuff or whatever kind of running in AWS anytime soon. Just because availability of our submarines is probably better than the availability of a zone. I hope. Do they float? Do they sink? I don't know. Maybe they fail up. Everything I know about submarines is from Red October, so basically I know nothing about submarines, pretty much. So I think the challenge here, though, is that for a lot of companies, you kind of have to break down this idea of. So how about this? I certainly remember AWS was launched maybe 1 year after AWS was launched, and that was at this point kind of a while ago. Even 1 year into it, people were like, man, this is just the future. Why does anybody even need to manage infrastructure anymore? Obviously, everybody's going to be running literally 100% of their stuff in Amazon. Who here is running 100% of their stuff in Amazon or Google or Azure or anything? There you go. So I think it's important to distill the promise of these things. I think the important lesson is there's the promise of all this stuff, and then there's basically, how do we actually, I think people eventually realize, like anything in IT, it's like, okay, these are tools, how do we actually apply these tools in a way that makes sense for how we do business and what our workflows are, right? Because not every workflow even makes sense to use in a cloud type environment, right? So I think there's a lot of work that, is being done in this regard, but, I think ultimately, people need to break down what this actually means and figure out how it applies to their own business. But that said, like I mentioned before, I think IT has changed because now you're getting into a position where people are outsourcing things that are sensible to outsource. Like you don't necessarily, the buzzword would be like, it's not a core competency of your business. But if you're like a pure software company, maybe you don't really care about managing your sales leads or something like that. You can do that in Salesforce. Maybe you don't want to be an expert running your own mail server, in which case you use Google Apps or whatever it is that you want. And I think people are starting to figure out, I think different companies are trying to dial that in. Like what are the things that we actually need to keep in-house because it's important and we have to own it, we have to be really fantastic at it. And what are the things that, it's okay to actually shunt this to somebody else, to a vendor. But why do they do that? Again, it's so that they can free up their brains and resources to focus on problems that actually matter to the business. But I do think an interesting part, I think an interesting ramification of sort of, now the overall acceptance of kind of cloud computing is basically, there's sort of an aspect of elasticity to infrastructure that maybe didn't really exist before. It wasn't as prevalent before. But now, quite literally, you could, with a credit card, with a high enough limit, you could burst to have, several hundred or a couple of thousand, Amazon instances. And then when you're done with them, you can shut them down after a couple hours. I mean, that's a pretty profound change relative to maybe like a decade ago. Or the world where if you want new systems or you want new gear, that goes through a pretty lengthy provisioning process. So if you can do things like that with that kind of speed, what does that mean? How does that actually change your practices and what tools that you use? Ultimately, there's no real future I see that takes less advantage of this kind of stuff. And I think because of that, there's also no real future for IT that doesn't involve more higher level tools and more automation in order to deal with this. Because the only way you can burst to have a couple of hundred systems spun up really quickly and then torn down is through automation. Because if you have to log in and actually do all that stuff manually, what's the point? Why would you even bother? Just buy real gear. Similarly, I think containerization is also, that's a big, that's obviously, it certainly has a lot of mind share, I think, currently. But I think similar to virtualization in general, and similar to a lot of cloud or elastic infrastructure, I think people are, again, trying to, we're sort of and I think you can see this, like literally if you follow the community or you're a committer to any of these projects, you can see kind of people trying to figure out what exactly this means to their organization. And I think there's a lot to still be sorted out, even if you're the upstream maintainer, like even if you work at Docker. For example, well, how many people are actually running production workloads on containers? Okay, so a handful of folks. How many people are like, Docker, that's a bunch of bullshit because Solaris had this in zones, like, And how many people are like, those people just never worked with a mainframe that had this stuff like 30 years ago? All right, no mainframe hands? It's okay. We'll wait till the happy hour and then maybe people will start admitting things that they're proud of. Okay, so one big schism is if you have a container, is the preferred way of deploying them that you have one process per container, or that it's more like a lightweight virtualization. It's a VM, but it's way cut down and you can spin them up faster and tear them down faster and you get better density. No one knows. The truth is, people do both. And there's no real established pattern for that. And I think as a consequence of that, that's why you see there are literally hundreds of projects built on top of Docker that are like, here's a different way to assemble containers together. Here's a different way to control deployments. And everybody's kind of getting involved. There's not really a or anything like that. So, I think the important thing to take out of this in my mind is that I do think one positive benefit of all this stuff is, A, the technology is kind of getting out to more of the masses, which I think is good. And B, I think oftentimes in order to really take advantage of things like containerization, kind of like virtualization initially, it really forces a lot of companies to have to think about how their applications are built and structured and delivered. Especially if you're trying to get into this more, certain people have been talking about this even before containers kind of came along. Like Netflix is a good example where their operations is very much oriented around the principle of immutable infrastructure. They were doing this prior to containers, with virtual machines and Amazon and things like that. Yep, we spin up systems, and if we ever need to make a change, we just burn them to the ground, we rebuild new ones, we push them all out there. And that all sounds great, but the challenge though is your software has to be built and constructed in such a way where that can work, right? Like, you're not gonna do that with an Oracle DB or something like that, right? I hope not. Or, if you have like a big ERP system, or, it's third-party software that you don't have control over how it's actually built and constructed. So not everything is built in such a way where you can, it's very easy to say, oh yeah, just immutable infrastructure, just tear it down if you ever need to make any single change. How many people currently are running infrastructure where you could literally, to make any change, tear the whole thing down, bring all of it back up, and that's not a disruption? There you go. I mean, it's not as easy as I think the hype would lead you to believe. The good news is that I think there are smart people kind of working on all this stuff, and I think eventually we'll kind of get to the point where we'll settle on some patterns and things like that. But for now, I think the thing to read out of this is you have to understand what the implications are here for your own workloads and what it means for your own business. So shadow IT. This is sort of the concept of, like I said, I think before oftentimes system administrators were kind of in the business of saying no to people, or institutionally there are a lot of gates that prevent change from happening. I think what you're seeing now, though, is that if you say no, people just figure out a way around you. Because, the band plays on, right? The business still needs to keep going. Developers are still need to spin up new systems and do testing. People are still going to have to do stuff. Your marketing department that can't get a file server stood up fast enough with enough storage is just going to start storing random stuff in Dropbox. Your developers who can't get systems provisioned for them for testing fast enough are just going to put their department credit card in and spin up a bunch of nodes in EC2, which is all fine, except that IT serves a valuable function. And the reason why you want to consolidate some of those things is because there are probably company-wide policies and patterns you want to apply. You don't want your marketing and sales staff to necessarily you don't want to have a free-for-all on some random Dropbox account with a shared password that doesn't, that's a huge security liability. And potentially, depending on the business you're in, might be illegal. So you don't want to do things like that. You don't want to necessarily have developers, going out and self-provisioning by swiping a credit card on EC2, because you may end up with, at the end of the month, your company is like, why do we have a $78,000 EC2 bill? Because people forgot to turn off their M1s for larges and they left them on 24/7 for a month. Right? These are things that happen. There are literally startups that exist to track runaway EC2 instances that needed to be shut down. That is a thing. That totally exists. So, I think we call that shadow IT. It's basically people doing IT stuff, but it's not the IT department. And, I think the challenge here is, we want to narrow that so that there basically that doesn't exist. IT is perfectly capable of actually servicing everyone's needs, so that they don't need to kind of go off the grid and do these things that potentially could be a liability. But essentially, shadow IT is competition when traditional IT can't keep up. So what's the way out of that? Well, people need to keep up. We need to move faster. We need to be able to provide the services that people are asking of us, but in a way that isn't onerous. It's not a maintenance burden. It's stuff that we can fit into our brains. All right. So now, what do we do? Why am I even saying all this? So, in general, where Puppet Labs comes in is, we're sort of the automation arms dealer, right? We don't care what business you're in, but I'm pretty sure whatever business you're in, you could probably do the things you're doing faster. You probably could benefit from being able to do them in a way that was more reliable, more testable, with better change control, and all of those kinds of things around it. So in a nutshell, what we try and do is make it easy for you to make rapid, repeatable changes to your infrastructure, which is sort of very high level and generic, but ultimately we want to make it easy so that you can automate common configurations of your environments, because if you can automate that kind of stuff, you can get stable configurations. You know how everything is supposed to look. There are no more snowflake machines. Why is this port open? Who messed with this thing? Why was this package installed? How do we stand up a test simulated an environment that's an exact copy of the one that we're running in production? You can't do any of those things unless you have some kind of configuration management and some kind of automation in place that lets you do things reliably and repeatedly. And the benefit of that is once you can get that sort of substrate, that allows you to deploy things onto that infrastructure much more frequently and with a much higher degree of confidence. How many of you have a test environment that's separate from a production environment you can deploy stuff into? Okay, so that's pretty good. How many of you have deployed stuff to a test environment that broke when you deployed it to a production environment because there was a difference? That's literally everyone raised their hand, right? So, it's almost a topology, right? The smaller you can make that gap, reduce that diff to nothing, then that's directly related to fewer failures that you would actually see. But you can't do that without this idea of kind of configuration and without configuration management and sort of automation at its core. So specifically, currently what Puppet is in the business of is, we have abstractions, both kind of built into the tool, community supplied. It's kind of all over the map to manage most of the bread and butter things that I think people are probably managing. Everything from users and groups and SSH, maybe not SSH if you're on Windows, but all these sort of ground level primitives. And obviously you can assemble these together to make higher level primitives. Like if you combine a user, a package, and a service, then that's basically like, it's a daemon that you can manage because those are that's the trifecta, that helps you manage one of these things. So ultimately, these abstractions kind of let you describe how you want these things to look, and then the tool just goes through and actually makes the system look that way. And it can do that over and over and over again, even without you looking. So the system basically, kind of makes sure that all of your infrastructure is in line with what you want it to look like. So I don't need to talk about this too much, but again, the benefit of actually doing this is that you can make more changes more quickly because you can iterate faster, because you know how everything looks. If all of that is stored in code, I can go through sort of standard like code promotion sort of workflows that people in development have been using for a really long time. And that gives you a higher degree of confidence when you want to push changes out than you would have had before. It's sort of comparing a tool that has higher level intelligence about how your infrastructure should look and the kind of change you want to roll out versus here's a Word 95 document that's 20 pages long with 1 million steps in it, and I really hope you don't get one wrong. But that's kind of what it is. Who here has deployed a tool using a Word 95 document? All right, maybe not Word 95. When did they introduce the red squiggly line? I don't know why they even make new versions of Word. Like, what are they doing? Spell check. That was game over, man. And lastly, it's I think the insight is important. Like, it's not sufficient, I think, to just new bits needed to be deployed, and now they're out there. Job well done. Time to go to the pub. Because obviously you need to know, well, how did that go? Or is the service actually working, correctly? The metrics that we track to make sure that the service is up and running, like, are those still good? Are they not good? Did the configuration change actually take on all the systems, or did it only take on 99 out of the 100? And all these kind of, if you put them all together, I think that ends up being a pretty powerful toolkit that you can use for a wide variety of problems. So the approach that we take is basically these 4 pieces. Rather than sort of the traditional way of doing things, if you want to automate stuff, is like, okay, well, you write a script, and it's 100 lines long, and it does these 15 different things. But how much of that script is reusable if you want to deploy another piece of software that maybe is very similar? Well, okay, maybe you can copy and paste some of it, but that's not super great. What happens if it crashes halfway through? What happens if all your security stuff is at the bottom, and maybe you have an error in the middle? There are all these kinds of things that I think people don't think about necessarily because the script is really, really easy to write. But the way we approach it is, instead of thinking about it as a procedural series of steps, think about it instead, the last one would be, can you rerun that script more than once? Or is it going to obliterate a bunch of stuff? That's usually the most common thing when people have existing automation is it's not repeatable. So what happens if it fails? Can you run it again? Is it going to automatically fix stuff? Who knows? So the idea behind defining the desired state of your system is, these are computers. Computers are pretty smart. You should be able to tell them what you want to have happen and let the tool figure out how to make it happen. You don't need to know whether it's user add or add user. I literally still don't know which one it is on whichever I don't know why there's 2 of them. That makes no sense. Somehow I blame Ubuntu for this. But why does that even matter though? Because what you really want to say is, I need a user with this ID, and there's the home directory, and these are the groups that they belong in. That's what you want to say. What you don't care about is the specific commands, the mechanics, what flags, in what order. That doesn't matter. So if you can define that at a high level, the tool can figure out, based on whatever operating system you're on, the right thing to do in order to make that user actualize, right? And then if you have that model, the system can actually test what that config would look like if you tried to roll it out. If you have your script, I'm pretty sure it's just going to be like, I got to create the user, and it tries to create it. What if they already exist? What if you don't want to create the user yet? You just want to know if you would have to create the user, and you just want to see the commands that would be run. That's stuff you can't do unless you have a higher level description or a model of what you want to have happen. So what Puppet lets you do is you can define all these things, and we could say, do a simulate like a dry run, where we can say, you know what, you told me you need these 10 users, these 15 groups, these packages are installed. I'm going to interrogate the system to figure out what the delta is between that model that you have and real life. And I can report that to you, and then you can noodle on that for a while and figure out what you want to do with it. And that's immensely powerful. And then, of course, if you're ready to flip the switch, you can enforce that change, and the system will actually be brought online, and then you can send a report of what it actually had. So how does this all work? And again, for people that have used Puppet, this is going to be an old hat, so I'll try and breeze through this a little more quickly than normal. This is an example of Puppet code that's set up SSH, so I apologize for the people that are primarily Windows oriented, but we'll get to you in a second. One thing to notice is that it really is intended to look more like a configuration file, as opposed to, writing C code or public static, void main, whatever, right? Like it's meant to be more like something a human being can read. And we have plenty of companies that'll literally hand Puppet code over to, say, an auditor and say, this is the stuff that the tool enforces, and they're like, oh, okay, here you go, because it's somewhat obvious. Like I need to have the OpenSSH server package installed, and I need to do that before I actually manipulate the config file for it. That's where the config file is, and it comes from, a central server where you have like a template of what that's going to look like. You need to make sure that it's owned by a certain person with a certain UID. And then I have the actual daemon itself, where I want to make sure that that's running, it's enabled, which means it'll start when you boot the machine up. And I could say whenever that config file changes, bounce the service or do a reload. So this is all basically comprising the model of something that's pretty simple, right? Like this isn't rocket science, but again, this is maybe 20 lines of code. And it's probably, if you were to write out literally the set of steps, like what you wanted to do, it'd probably not be too much shorter than this, right? But what this lets you do is on any system, you could go to that, run this maybe in dry run mode, and you could say, does the system already have all this stuff? What's the delta? Maybe it doesn't have OpenSSH server installed. Maybe it has it installed, but the config file, like it has iCloud protocol version 2. Probably shouldn't. All kinds of sort of nice benefits there. Here's an example where you could have the same code that would work, basically it can do dispatch based on maybe the type of operating system they're actually running. So if this machine, this is like common base config for a system. If you happen to be a Windows system, maybe I want to install IIS, I want to install SQL Server or something like that on it, but if it's not, if it's a Red Hat system or a Debian system, I want to install all these kind of base Linuxy things that I want to have on there. And it's a high level thing, and you can see the include keyword, and that basically says, there's some other code somewhere, either you download it off of the Forge modules that other users in the community have written, or stuff that within your own organization you've written yourself, and you can reuse those building blocks. So again, this kind of looks like a config file, but what it's really getting at is you kind of define what the Lego bricks of your infrastructure are like, and then you start just describing really basically like how you just snap the bricks together. That's pretty nice. And for the Windows folks out there, how many people have Windows machines in their infrastructure that they're responsible for? Yeah, all right. There you go. It's serious business. I'm a big fan of Space Cadet Pinball and Microsoft Concept. The last time I touched a Windows machine was evidently in 1995. But it follows the same principle, right? Like, 'cause obviously Windows has packages, though they're a little bit different. Windows has more of a need to reboot the system after certain packages are installed. There are certain things that are specific to Windows, like features that you want to turn on. Through the control panel and things like that, or MMC. So the point here is that with the same sort of approach, you can kind of describe a wide variety of things that you want to configure. And Windows and Unix systems are fairly different under the hood, but you can use the same tool to address them with the same concepts. So, basically, here's kind of the flow of what ends up happening. Like, there's basically a central server, you have your Puppet server, Puppet master, and then you have kind of our agent code that lives on all the target devices. And I know these are servers, but we also have we have support now for network gear. If you're running like Juniper or Cumulus or a few other like Cisco, a few other things like that. Like you can also have agents that run on there as well. Unless you really like telnetting in and running iOS commands or something, which I don't know who that would be. But the overall flow of the system basically looks like this. We've got a central server, and you have all these agents. The first thing they do is they kind of wake up and they say, okay, well, I need to collect some information about myself and send sort of a data packet to the server that has all the metadata about me as a server. What my host name is, my IP address, how many interfaces, net mask, whether I'm physical or virtual, how much RAM I've got, how many cores. There's like hundreds of them. on a system. But all that information is potentially useful because maybe you want to have a config file that, for example, says, on this server, I want to spawn n processes for this service where n is the number of cores that I have, right? Wouldn't it be nice if that same Puppet code worked on a 2-core system or a 32-core system? Why shouldn't it, right? Because the model is the same. The model just says, well, however many cores you have, use that number for this aspect of the config. But all that has to come from the machine itself. So that's what it does. And then what the master does, the Puppet master, is it basically takes that and it looks at your Puppet code for that system and it says, okay, well, what is the model of the system? Based on the input that you've given me, what is the desired state for this box? And we call that a catalog, which is basically all the resources you want to manage and how they relate to each other. And then we zip that back to the client, which then goes through that cycle where it actually applies all those changes to the local system. It makes the system look the way you told it to look, and then it sends you back a report of what actually happened. Part of the reason why we do this, and maybe something that contrasts Puppet from a lot of other tools, is that we do have a central server. Like, don't believe anybody that says that one architecture is inherently superior to another one, because I'm pretty sure that's never the case. So there are trade-offs here. I think the downside is that there are central services. You know, no one loves running more central services than they really need to, right? So that's a downside. And a lot of competing tools definitely do things like, there is no central server. You know, we just push all your config code out to the endpoints, and then they figure out on themselves whether they need to actually, what their config looks like. But the reason why we do it this way is primarily for security and control. Because if you have all of your config code for your entire infrastructure shipped to every single machine in your infrastructure, stuff that's in a DMZ, stuff that's not in a DMZ, like suddenly anyone who gets access to that can see how your entire, can see aspects of your infrastructure that they wouldn't be able to before. And this is kind of a standard IT thing, right? Like it's the principle of least privilege. So by having this stuff computed on the server, what that allows us to do is if the machine on the right says, what's my config, the only information they get back is literally the smallest sliver of info that that machine needs to configure itself and not any other box, which is nice. But that's the trade-off, I think. So that's something, everyone here is smart, so I figure that's something that people should just be aware of. Because we have all of that data, so basically we send all these catalogs to systems and we get all these reports back. We have a project called PuppetDB, which is sort of the central data warehouse for all this stuff. And it's queryable via APIs and things like that. But what that does is it's a store of all that metadata, all that inventory information for all of your systems, the desired state that you want every single system in your infrastructure to have, and every report of whenever Puppet ran on that system. And that is all available, and it is all queryable for you to integrate into whatever tools you want. How many people work in an org where the primary means of tracking inventory is through like an Excel spreadsheet of some sort? Or you at least use one. Okay, there's a handful of hands. You don't need to do that. Just by virtue of installing Puppet everywhere, just by having it run through cron every once in a while, you will develop an inventory stored in PuppetDB that you get automatically, so you can say, how many systems do I have that are running this Linux kernel version? Because a vulnerability was released. It's super easy to figure out, and you don't need to like Control F in Excel. Excel is amazing. I genuinely think it's like responsible for like 50% of overall GDP in the world or something. Would not surprise me at all. So all that said, I mean, there is definitely the declarative view of the world, right? Like, I want systems to look like this. This is my model for how they look. I want to track changes to that model over time. However, there's still always going to be a need to run ad hoc commands. I mean, that's the way it works. You're definitely going to need for maintenance. You'll have to go in. You'll have to turn off the service for some reason temporarily. Maybe you'll flip it back on again, but that's not necessarily the model you want for that system permanently. It's a transient thing because maybe there's a maintenance window, there's an outage, or there's something you're trying to debug and things like that. So we have a companion project called M Collective, Marionette Collective, Puppets. Get it? I didn't make up that name. But this is basically for doing parallel execution in real time of commands that you want, and you can write your own sort of plugins and agents that live on your target systems, and you can tickle those to run whenever you want. So people have written specialized ones that will do complicated things like initiate a deployment or do like a phase takedown of a service so that you can do an upgrade and things like that. That's definitely the companion to the declarative view of the world. world. So there are plenty of things that you can and should be modeling up front, how you want your systems to look and how you want them to behave. But that doesn't, like any dogma, don't believe anybody that tells you that's the only way the world should work, because it's not. There are plenty of situations where you need to do stuff ad hoc, but in a way that's still structured and fast. And that's where collective comes in. For those of you who've been following development on the public mailing list, the IRC channel, probably one of the big things that we did when we announced this at PuppetConf was we came out with Puppet Server. Puppet Server basically takes the existing master that's sort of a traditional process model, like we spawn one process per core, there's an Apache fronting it, there's a passenger process that kind of puts all these things together, running a bunch of Ruby code, and there have been issues with that. Probably the big one is that it's a lot of moving parts involved. So at any point in time, either like the Ruby process that gets spawned could have a problem, or passenger could have a problem, or web server could have a problem. So it's just more that people have to manage. And lastly, just from a performance standpoint, like if you only have 8 cores in your system and you have more than 8 systems that want to get a configuration compiled, then you end up queuing, so it has to wait, because that's how physics works. So what we've done in Puppet Server, and this has already been out for a bit. 1.0 was a while ago. They're about to kick off. I think 2.0 is going to get cut pretty soon. Probably have 3.0 in a couple months, something like that. And it's already in Puppet Enterprise 3.7, so if you're running that version, you've already got it. But what that does is it basically consolidates all that code into a single process with a lot of these features just embedded into it. So you no longer need to have Apache, passenger, set your Ruby lib, do all these kinds of things in order to connect all these pieces together. There's just one process, kind of like how PuppetDB works. There's just one process, you start it up, it has an embedded web server, it does all the SSL for you, it's its own CA, it manages a pool of JRuby instances that automatically is scaled to how many cores you have, and it can scale up and it can scale down. And the straight line perf, and you could look at our blog for more numbers about this, the straight line perf is considerably better than what we got out of the passenger stack, just because there's an actual just-in-time compiler and a whole bunch of other nerdy stuff that I could talk about way more if you come and find me. But especially during saturation conditions, when the system is mega overloaded, we give you the ability, it has the ability to maintain that load without erroring out. Stuff will delay and stuff will slow down, because again, that's how physics works. But it definitely has some improved robustness and reliability capabilities there. What we can also do is, in case you need to do actual provisioning of systems, how many people are still managing like physical gear? Okay, all right. So there's still definitely use cases around like actual, Pixie boot provisioning, that kind of stuff. So we have a project called Razor. Scott McClellan in the front row works on that one, so if you have any questions, you should talk to him. And that's basically a rules-based approach to doing provisioning. And it's anything that's sort of Pixie enabled, right? Like, so, it can be physical machines, it can be virtual machines, it's sort of whatever you want. But you describe qualitatively how you want your systems to look. Like you say, if a machine Pixie boots and it has these characteristics, it has this many cores, it's in this geo, it's on this subnet, or I don't know, whatever it is, right? Then you can say, okay, well, that's a database machine. So here's the operating system it needs with this version. Here's the kickstart file. Here's the disk layout that I want it to have. And you can automatically do that. You don't have to put in, like, every time I order 100 new servers, here's 100 new lines. I got to put in some dumbass tool that doesn't understand higher level context, which is what Razor is for. And Scott's done a really good job with that. One big thing that we've done, and it's going to be showing up in the next version of PE, and a lot of people have probably been using it on the open source side, is R10K is a very popular tool that we developed in-house. One of our engineers built it maybe 18 months ago to manage modules that exist in different Puppet environments, and making sure that you can kind of point at their upstream GitHub repos, you can point them at the Forge, so it's a way of like maintaining all your modules, updating them, and making sure that the right versions get into the right directory so that you can stage systems through all of your Puppet environments in a sane way. So that's going to be just folded straight up into the next version of PE, so it'll be properly productized. But even if you're not a Puppet Enterprise customer, it's fully open source and available today. But I guess I'd say this to say that, I bring this up to say that's probably the standard, in how people manage their modules, I think, at this point in time. 2015, pretty much most people are using R10K. And in fact, many of the features we've done on the open source side, like directory environment support in Puppet 3.7, is pretty much based on how R10K works. So I encourage everybody to actually check it out. So I want to talk a little bit about, really quickly, some of the stuff that's coming in future versions of PE, for those of you that are currently using it. There are basically going to be multiple applications that are going to be sitting on top of, there's the Puppet, kind of open source, there's sort of the platform that exists, that's kind of that bottom rung, right? But then on top of that platform are a bunch of applications that kind of interact with this foundational layer to do more interesting things. Node Manager we released in PE 2.7, I think was the first cut of that, and that's basically the node classifier that exists inside of PE. And similar to Razor, again, this is a rules-based approach for how you classify your systems. You don't need to say, if you have 15 new systems to provision, I gotta go into a Puppet a Puppet file, crack it open, add like 15 new stanzas for every single system and say, this is an app server, this is an app server, this is an app server. What you can do instead is you can say, again, any system that checks in that happens to be in this data center or this availability zone with a name that matches this regex with this many cores, it's just an app server. It gets this Puppet code applied to it. And if you set those rules up, you don't really need to maintain them. Like, you don't need to hand tweak them over time, as stuff kind of goes on, right? Like, the system sort of takes care of it for you. So again, a higher level tool that jives well with sort of how Puppet models the universe under the hood. So that saves people a lot of time. There's the operations manager. Puppet server, when we ship it in PE, is instrumented out of the box with a ton of data about, and this is mostly for people that are super new to Puppet or that are running very small environments, probably not mega useful. But if you're managing hundreds, thousands, or tens of thousands of systems, like this is the kind of stuff that would be pretty nice. Where it tells you, for example, we have information for every function call you're making, all of your Puppet code, for how long compiles are taking, how long it takes to process reports, what is the current request queue, average queue length for like all variety of things. So this is the kind of stuff that as an administrator of your Puppet infrastructure would be useful. And this data is just exported to, this is a Grafana, which runs on Graphite, which is a time series database that's freely available. So we can pump data into there. You can use this dashboard, make whatever dashboard you want. That kind of fits into that and layers on top of it. So it gives you way more insight into how Puppet is actually working. So you can know, do I need another master? Do I need beefier gear here, more cores, etc. And lastly, there's sort of, we have a feature called Event Inspector, but that's mostly about insight. So again, if you actually have a change that you've made in your Puppet code and you want to deploy it, one important aspect of that is you want to know what happened, right? Like, okay, I deployed that change and everything returned with a 0 instead of a 1, so I guess that means everything worked. But what does that really mean? Like, the changes that you wanted to have happen, did they actually have happen? So this is a GUI inside of PE, and PE you'll see kind of more future versions of this that really double down on this idea. But you can kind of see, you can, at a per node level, you can say for this node, what were the changes that happened? Within a time window, you could say for this window of time, what changes happened. But it really allows you to figure out what was Puppet doing and why, and did it go well? Which is pretty great, because that's a core thing we want as an operator. So I'm basically, just to wrap up, I would say the reason why all of this stuff matters is, again, the more you can automate, the more your brain is hopefully freed up to actually focus on problems that you genuinely for your business, right? And all of this stuff, on the one hand, it's just a tool. On the other hand, it's a tool that should help you actually sort of wrangle all these things that are historically very difficult for you to wrangle, and allow you to actually have some free time to think about, like, maybe we should look at a different operating system, maybe we should reconfigure how we do the network, or change how we do provisioning. Higher level things that are much more strategic. So if you want to get involved, there's tons of ways to do that. Puppet, we have a huge open source community. We're like I think 9th or 10th biggest channel on Freenode. We moved up one slot because Dogecoin was really popular for a while and bumped us down, but now we're not. So there's definitely plenty of ways to get involved. The mailing list or IRC, come and find me or anyone with a Puppet Labs shirt on, and we can help you get involved. There's plenty of ways to learn. If you're interested in Puppet, for a lot of the newbies in the crowd, you're going to see a ton of information today. But if you want more information, you can go online to puppetlabs.com/learn, and there's a bunch of videos, interactive exercises that you can actually do, and it tells you how you did. You can do that all from home, and it's all free, which is pretty great. For those of you who know stuff but maybe want to know what new features are coming, what bugs have been fixed, how a particular feature works, the documentation site is excellent. We also have it in Spanish, and we're working on more languages. I think Japanese is probably going to be coming up sometime fairly soon. For anyone who speaks Japanese, I don't, but it would be pretty sweet if I did. I'd understand those cartoons a lot better. And lastly, if you need more help, there's definitely training and certification that we do. This is all info available on the website. One important thing to note that's not listed on here is we now have stuff that's Windows specific. Because again, if you're a Windows admin and you go into a class and it's like, yep, SSH in and then fire up VI and then make some bash aliases or whatever, that doesn't resonate with them, right? That's not the tool chain that they use. So we have Windows specific training for you or people in your org that are like that. And I would encourage everyone to join the Puppet Test Pilot program. Really quickly, this is basically a program where you can express your interest in new features, just ideas we want to have. We'll do random things we'll call out test pods. Hey, you work in an org where you manage more than 150 servers and some of them are Red Hat. Great, here's a piece of code. Just look at it and tell us what you think it does. Because we're testing out a feature and maybe is it inscrutable or does it actually make a ton of sense? We don't know, which is why we need to ask everybody. So we need your help. And this is an easy way to help. And you don't have to be a developer. This could be anybody. It's just someone who's willing to spend some time and help. And I think we sent you some free swag, which is pretty great. And we're hiring. So I'm sure you all love your term. For those who don't, come and talk to us. And if you don't have time for me or anybody else, if you don't get a chance to chat with us today, I encourage you to come to PuppetConf, which is going to be in October in our home base, not my home base because I'm based out of Denver, but in our home base in Portland, Oregon. So I encourage you all to show up. So I think that's it. Thanks.